Hello everyone. Let's take a look at our next problem. How many zeros are in 100 factorial? Okay, so I have actually seen a question just like this before, so I kind of know what approach I would take. When we're in base 10, well, actually, I suppose this question isn't exactly like something that I've seen before because it asks how many zeros are in 100 factorial. The version of the question I've seen is how many zeros are at the end of 100 factorial. So the way I've seen to approach a problem like that before, how many zeros are at the end? Well, in base 10, a number will end in a zero if it's a multiple of 10, and the more multiples of 10 in its, well, 10's not a prime, but if you prime factor the number and then group together pairs of 2's and 5, the number of pairings that you can make will be equal to the number of zeros at the end of that number. But this misses all of the zeros that may not actually be at the end of the number. So, for example, if I have the number 1020, there are 2 zeros here. Now, I know for sure that if I do prime factorization of this number, there will be at least 1 power of 2 and at least 1 power of 5. And for either the 2 or the 5, there will be only 1 prime factor. So this is going to be equal to something like 2 to the n times 5 to the m times q, where n greater than or equal to 1, m greater than or equal to 1, and both of them cannot both be greater than 1. But that's not what the question is asking. The question is asking for how many zeros in 100 factorial. So how would I go about this? How do you find the zeros that are earlier in the decimal representation? Well, let's first count how many zeros are at the end of 100 factorial. So what we need to do, again, is we need to count in the prime factorization of 100 factorial, how many 2's are there and how many 5's are there. Now, there are certainly going to be more 5's than 2's. When you're multiplying successive integers together, you pass through more powers of 2, or you pass through more even numbers than you do multiples of 5. So there will be more powers of 2 than there are powers of 5. And so we really only need to count how many powers of 5 are in the factorization of 100. If I just start writing out integers, and so on, we have a power of 5, or we have a multiple of 5 here, we have a multiple of 5 here, then we'll have one at 15, one at 20, and one at 25, and so on. But anything that has 2 multiples of 5 or 2 powers of 5 in it, like 25 and its multiples, we'll have to make sure that we count those twice. And anything with 3 multiples of 5, like 5 cubed, and multiples of 125, we'll have to count also 3 times. Okay, so number of Okay, so 100 divided by 5 is 20. There are 20 numbers between 1 and 100 that are multiples of 5. So if we kind of tally or take a total here, total occurrences of 5, it's going to be 20. And then if we divide by 25, this is 4. So we have to add another 4 for multiples of 25. And oh, I guess we don't care about 5 cubed, right? Because 125 is greater than 100. So there's going to be 24 zeros at the end of 100 factorial. How do we find the zeros that are earlier, though? Well, we've seen before 100 factorial, this is going to be equal to any decimal, any number in decimal can be written like this, a sum of powers of 10, where these numbers just represent the digits in the number. It doesn't really matter for now, but maybe this should be a 25, but I'm not really concerned at the moment with whether that should be a 24 or 25. I'm trying to think about if there's a way to see if any of these. Well, this number A24 definitely cannot be 0. We know that. Because if it were 0, then it can only be 0 if we have an additional multiple of 5 in the factorization. But how do I? I'm going to try this with smaller numbers just to see what I can figure out here. Why don't we skip why don't we try 10 factorial and see what happens? I don't remember what 10 factorial is off the top of my head. Maybe a table of factorials would help here. I think 7 factorial is 4050, but let's figure it out here. Okay, well, not quite. So here's what I mean with the technique that I had above of counting the factors of 5. It only gives zeros at the end. This 0 would have been missed in the expansion, as would this one. Just so happens 10 factorial only ends in the 2 zeros that would have been picked up by counting factors of 5, and there aren't any other zeros here. I'm just going to do some arithmetic here and compute more factorials to see how often some extra zeros come up. I'm not going to do it by hand. I'm going to bust out my calculator here. What if, okay, so this is the first time, this number here is the first time that a 0 appears not at the end of the number. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2. What happens if I write this as 7 times... Oh, no. I was going to start breaking these numbers up into sums of 2 numbers to see if I could, there were like a way of expanding. I'm just going to try something here. I don't know. This is not, this is likely not going to work, but that's okay. 10 minus 3 times 10 minus 4 times 10 minus 5. if we could, divide by 10 and is there an easy way of taking a number, dividing it by 10 and computing the floor? I mean, I'm really not sure anymore. My hunch here, my honest hunch, is that the source of this question probably intended to ask how many zeros are at the end of 100 factorial, not how many zeros are in 100 factorial. But yeah, it's interesting how tiny little change of the question can make it so much more complicated. I don't even know what I would try next. I was hoping that maybe by writing things in some kind of form like this, I'd be able to, we're clearly going to get a lot of things multiplied by tens, and maybe we could then expand something like this. The problem is a lot of these numbers, a lot of the A1, A2, A3, or so on would end up being negative, which is not really how the decimal expansion works. I really don't know. The question is a lot more difficult than what it first seems like. But anyway, thanks for watching.